This video is meant to complement the instructions provided in the Trail Assessment Final Project. Hopefully by now you've had the chance to read over the PowerPoint regarding trail accessibility in trail classes, as well as the handout on design parameters that can be used to identify a trail class. The ultimate goal of this project is to develop a RAC card that includes accessibility information and some leave no trace principles that we've learned so far in the semester. Other information can also be provided. It can be creative. Here's a couple examples of RAC cards that were produced by students in my other classes, and I also provide these examples in the module. The Universal Trail Assessment process relies on inexpensive and easy-to-use tools to reduce costs and to simplify the process. The process was developed for volunteers with little or no experience. The equipment that you will need for this project includes one tape measure, one nail long enough to wrap 6 feet of string around, and a string level. A string level can be purchased at a hardware store or at Lowe's for less than $3. The first step in the trail assessment process involves selecting a trail. Select a natural surface trail like the one shown here. Don't select a trail that's been paved or has an asphalt surface. Preferably select a trail on public land, or perhaps you have a trail on your own private property that you'd like to assess. The trail should be between a quarter mile to 1 mile in length. Trails longer than 1 mile would require more sampling points. In this project we're going to have 10 sampling points. And if it's possible, select a trail from the West Virginia Trail Inventory, but this is not required. The West Virginia Trail Inventory provides information that you could include in your RAC card if you desire, such as trail profile. Measuring tread width. Identify the endpoints of the trail tread as the most pronounced outer boundary of the visually obvious human disturbance created by trail use. These boundaries are defined as pronounced changes in ground vegetation height, trampled versus untrampled. The objective is to define the trail tread that receives the majority of traffic, about 95% or more of the traffic. Selecting the most visually obvious outer boundary. In this case, the trail tread is 24 inches. Measuring cross slope. With a line attached to a stake or a nail on the high side of the trail, extend the line to the opposite side of the trail roughly perpendicular to the main tread. Make sure the line is set at ground level. Attach a line level to the line and level. Measure the height of the line from the ground on the low side. Record your results to the nearest ½ inch on your data sheet. You can calculate the cross slope by dividing rise over run. In this case, 2 inches divided by 24 inches, which is the trail tread width, which equals 8.3%. The final trail accessibility factor that we will measure in this project is trail grade. Trail grade is typically measured using a clinometer, but they're expensive. We will use a simpler method, the same method that we use to measure cross slope. First thing we need to do is measure the running distance. I selected 5 feet. That should provide accurate information. If you notice that your grade break occurs in less than 5 feet, then use a shorter running distance. Next, make sure the line on the nail is set at ground level. Attach a line level to the line and level. Finally, measure the height of the line from the ground on the low side. In this case, it's 7 inches. To calculate trail grade, divide rise over run. Divide 7 inches by 60 inches of run. Trail grade percent is then 11.7%. Record this on your data sheet.